Hello. What you're looking at here, and the job I have today, is to machine some of the parts required for this assembly, which is what's called a casing support. It's an improvement over a design I made a couple of years ago for the Auger Boring Machine that I designed and built. I had a series of videos a few years ago on my channel showing the design and build of that. It's been used now a few times, or a few different jobs. I've actually done a fair number of shots under highways and that with culverts, and they've after using it now for a little while, they've come up with a list of improvements they would like to see made to it, and this is one of them: to have a roller type casing support. Essentially, these two parts would sit on the front of the machine like this, orientated like this, with the two parts at a 45-degree angle. And then in here is the casing, which is a large piece of pipe from 36 to 48 inches in diameter. And this essentially holds the one end of the pipe up in the air while the machine pushes on it from the other end. You want to have it threaded so that you can adjust for the different diameters of pipe. And my original design, this threaded rod just ended in a flat plate instead of a yoke and roller, which is what we have here. And because of that, the orientation didn't matter. That flat plate looks exactly the same to the casing, no matter what position it's clocked to. So we were able to make the adjustments by rotating the threaded rod inside of a tubing that had a solid nut in it. Because they wanted a roller, the roller obviously has to present itself at a certain angle. We can't rotate it, to whatever angle we want. It has to stay in this orientation, but it needs to move in and out. So in order to do that, we've made this split collar here, and this threaded rod will be inside of here, and then a nut will sit in here, and you'll be able to spin the nut, and this will move that way or that way. There's a key in here, and there will be a keyway machined here, and that's to prevent this from rotating. So we'll be able to keep the roller aligned in the orientation it's supposed to be in, while also being able to move it up or down. Today's job is simply to finish off the threaded rod portion. So there's the slot has to be cut in the yoke, which on this one I've already done. I have another one that hasn't had anything done to it yet. Then a hole put through here for a shaft to hold the roller. And then a keyway has to be cut over the length of this. And it has to be full length because the part has to be inserted from the top end in order to fit. Along with that, I have to make a nut, which probably won't be included in this video. And I also want to make a bit of a bronze thrust washer. It'll just be a washer that sits in here that the nut can spin against, just so I don't have steel on steel, which is a recipe for galling. When they tighten this nut, there'll be times where there can be pretty big loads on this, actually. The casings themselves can weigh, I think they can weigh up to about 3,000 pounds, so this would see roughly half of that. But where you get the really big loads is when the casing is being pushed in the ground, and if the end that's in the ground starts to deflect downwards because of frost or other things in the way, it can really push down on these supports with a lot of force. So it's got to be pretty solidly made. And then, of course, while it's being pushed down like that, they may want to make an adjustment. You usually do all your adjusting when you're putting the first casing in, and in fact, after the first casing's in, these don't get used anymore. And it's the first casing that goes in that'll do any of the deflecting. So it needs to be fairly substantially built, and I wouldn't want this to pick up and gall, because if it galled enough, it would it may pinch the nut and just make it so you can't even turn it. So so this is one of the yolks that's been welded together, but this hasn't been cut out. So that's my first job. First job is to face this end to length and then machine out the slot for the roller. After that, we'll set it up and machine the keyway. Now to hold this, I'm going to hold it in this V-block fixture. And I have the table this way, pointing away from the spindle. And I find that probably the most use the rotary table on this boring mill gets used for is loading. When I put it in this position, I don't have anything underfoot. I can stand right in here and I can work on the this whole end of the table, and then when I get the setup done, I can just rotate the table 180 degrees and present this end to the spindle. Very handy. Trying to load this from this side, which would be the normal way you would load it if you didn't have a rotary table. The outrigger and the outrigger extension there, in order to avoid those and not be tripping over them while you're working on the table, which you would say in this position, you have to bring the table so far forward that you then have interference from the head, and it really just it cuts down your room to work. And I tried it when I first got the boring mill, and it was a pain in the ass, and I quickly discovered I could move it over to this location and have a relatively easy go of getting things set up. So that's what I do from now on. Anyways, we'll get it loaded and we'll show some of the machining. Well, I kind of screwed up. I machined the second yoke and did not get any of it on video. Apologize for that. It took to machine that yoke takes 7 roughing passes. It takes I take 5 passes, half an inch deep, just down the center, with 1.5 inch roughing end mill. That's this one. And then I take 4 finishing passes with 1.5 inch finishing end mill. Some of the swerve. The roughing end mill, it's too bad I didn't get it on video, because the roughing end mill does chew through the material really well, very smoothly and quietly. It's the finishing end mills that will tend to chatter on you if you've got a really big engagement. Like, you have to watch when you're doing this. I do it full depth of cut, but not very deep. Like the full length of the end mill is in, but the cut is not very deep. And you'll still have, it's always on the verge of chattering like that. Even in the boring mill, which is pretty rigid. This mill actually has less trouble with it, simply because the spindle on this machine, the spindles, both the horizontal and the vertical, are very heavy, and there's no, and they're solid. There's no boring spindle that slides through it like the quill of a drill press where there's a bit of clearance. These are just preloaded roller bearings, taper roller bearings, and it's extremely rigid. So they generally wouldn't have any trouble with that finishing end mill, but the boring mill sometimes will vibrate. So, but it did turn out well. And the next step was to cut a keyway, which I've done on this one. I haven't on this one, so I thought I'd show that next. But this is essentially the operation. This is just a temporary nut from the old assembly. The new one will be wider, and like I said, there'll be a bronze washer here, but essentially I'll turn that at an angle. That's how it works. And the key fits pretty close. There's very little rotation. But yeah, so it's working how I'd hoped. I've just put a little bit of oil on, but this will eventually all be greased up, and that'll hopefully keep things from rusting when they're not using it. So, so to cut the keyway, like most keyways, you need to find the center of, you need to find the center of the threaded rod in this case. Normally it's the center of a solid shaft. With a solid shaft, you can just come down and pick up each side with an edge finder, and using the half function on the digital readouts, you can find the center quite easily. This is a little harder to do because you would have to touch the edge finder on the crest of the Acme thread, and while it's probably possible, it's a bit hokey in that it'd be one of those things where it would be really easy for it to dance off to the side because there's so little surface area, and it would it's one of those things that can turn into a frustrating pain in the ass really quickly. So my solution to that is to hold this in a vise and clamp it, and then I can just take I can use the edge finder to pick up the back non-moving jaw of the vise, which will stay in the same location relative to the spindle, and then knowing how far from the knowing the diameter of this, I can just move half that distance, and that'll put me in the center. There's one other thing too. When you set this up, I want to have the keyway orientated relative to the sides of the yoke. So there's a way to do that as well, and I'll show that. Okay, so first thing we'll do is we'll pick up the back edge of the vise. Now it just kicked off, so that means that it's on the edge. And so that's on the y-axis. So I've made this chart which shows me how much to enter based on which side I pick up. So in this case, I'm coming at the back jaw, so I need to add 100 thou, because this edge finder is 200 thou in diameter, and then that'll put the center of the edge finder on the edge of the jaw. So just go Y, 0.1, load. Just kind of show. You can see it's off to the side. Now if I move that to 0, and you can see now that it's a little bit hard to see. Let's try it this way. You can see that it's pretty much on the edge there. So I'm placing it in the vise like that. The keyway is going the full length of the Acme rod, right up to partially into the weld. So for rigidity, or to keep things consistent, I'm trying to get the same amount of that hanging off each end of the vise. And then by doing that, you don't end up with, you could put this end right up to the vise, but then this end would be way out here. And it probably wouldn't matter. It's a small end mill and this is a big part, but it's just generally good practice to try and keep the overhangs equal if there's no other reason to prevent that. And then you'll have the sort of the best chance of it not vibrating. Unless it's, even when it's overhanging both ends equally, it's too flimsy to cut. But in that case, then you have to set up in steps or add some supports to it. So I'll get that roughly in the center. And then I need to orientate it so that this is straight up and down. And the easiest way is just with a square off the table. Put a little, just a tiny bit of tension from the vise to keep it positioned, but still allow it to rotate. When you tighten a vise when you're doing this, you have to watch too, because sometimes, it didn't appear to do it this time, but sometimes just tightening the vise will cause a round part to slightly rotate in the jaws. In fact, that did happen here. I got a little wee bit. So I'll try tapping it back. I got a touch too far. I think that's pretty good. For this part, that's more than accurate enough. So we know when the Y is at 0 now. We know that the spindle center line is right on the edge, the front face of the non-moving jaw. And therefore, we need to move this over that way half the diameter, or the radius of the thread. And I've measured the thread, and I know the diameter, and I divide it by 2, and it comes out to 1.247. So we'll move over. Okay, so now the spindle is in the center of the screw, which is exactly where you want the center of the keyway. So what I'll do, I don't want to lose that back jaw reference, so I'll switch from absolute to incremental, which is just a separate coordinate system, and then I'll 0 Y. Zero the other ones, it doesn't really matter, but Y is the important one. So now when Y reads 0, it means that my spindle is in the center of the keyway. So what I'll do is I'll take, this is a 5/16 end mill, and I need to cut a 3/8 keyway. And I always like to cut keyways with I don't like to cut them size on size with the end mill, because the end mill always deflects and you end up with a parallelogram type keyway instead of a keyway with vertical sides. You'll kind of end up with a keyway that's shaped like my hands instead of vertical. So I always like to use a smaller end mill and plow down the middle and get it nearly to depth, maybe about 10 thou shy of full depth. And then, because the center line is 0, I can then offset the distance I need to widen the keyway out. So I can offset, come down to this end, come back to 0, offset the other way, and head back out. And now the keyway has been widened out. Usually it takes, you don't generally do it in one pass. I usually do it in 2. And while I'm doing that, I increase the depth of cut by the last 10 thou to get it right to depth. And then you end up with a keyway where the width is, very accurate as is possible to make it, because you're not relying on the actual width of the end mill. Your width is being determined by your offsets, which with a set of digital readouts you can control very accurately. It also doesn't matter if your end mill isn't exactly on size, because what you can do is after you do your first finishing pass down and back, then you can measure the width. And if you need to be very accurately, what I use are gauge blocks. I make a stack of gauge blocks up, and I keep making them larger until it just goes in. Then you know that the stack up on the gauge block is the actual width of the keyway, and then you can make any corrections in your offset from there. And doing that, I've had pretty good luck. I've cut keyways where when you put the key in, it slides easily back and forth, but you cannot feel any movement between the key side to side, which is what you want. In this case, I don't have to be that accurate, and in fact, I'll make the keyway a bit more loose than that. Simply because it's more important that this thing not seize up later on when it's outside getting rained on and crap's getting in there. You want to have a bit more clearance so that things don't just lock up. If this has a very slight rotation to it, like I was showing on the other one, it's not a big deal. It's not going to affect the operation of this machine at all. So better to have a bit more clearance, and then things won't seize up as easily, because if it's seized up, then the machine doesn't work until you can get it unseized. So So now we've got the end mill installed in the spindle, and we know we're in the center of the screw, so now we have to set our depth of cut. And I find the easiest way to do that is bring it up close. I like to have the minimum overhang in my quill, and then get over top of the crest of the thread, and then I like to just come down with the quill and touch, because you have very good feedback on the quill. You can tell as soon as it touches, you know, and there's no chance you're gonna jam the end mill hard into the work and break an edge off the end mill. Especially this, it's carbide, they fracture very easy when you do that. So if I tried to come up with the knee, because the knee is so heavy and there's so much gear reduction to make it possible to turn the handle, you don't get that sensitive feedback, and it's very easy to come up and hit the end mill and break a piece off before you know you've even touched it. So I usually do it with a quill, and then I just lock the quill, and then I zero the digital readout, and then drop the knee. And now I know that when I come back to zero with the knee, I don't use the quill after this, it's locked. In fact, I have a quill kit here that gives you a digital readout for the quill movement. I always zero it, and then I can tell if the quill is actually moved, if it got bumped or something. So anyways, that's how I set the depth. I'll set the depth of cut to 100 thou. In fact, no, I'm gonna go 150. I think it'll handle that. I was cutting a keyway where the depth was critical, I would take this to 390, and then when I was doing my finishing passes, I would take the last 10 thou for the depth of cut. But this, I don't need that type of fit. In fact, there's actually a gap between the bottom of this keyway and the key, and that's what I want. It's a place for dirt or rust to go, and also a place for grease to be held. Again, it just gives some more clearance so things don't wind up out in the field when they're full of all kinds of crap. So what I'm going to do is I'm just going to take this right to 400 in this last roughing pass, and then I'll widen the keyway a little bit. Okay, from the last one I did, I know that the finished offset is 34 thou. So I'll put this back to the depth of cut of 400. And what I'll do is I'm going to take a 30 down each side, and then I'll go to 34. Take a 4 thou for my finishing pass. I do want to try and get the width of this keyway pretty accurate. The depth isn't critical, but the width is more important. Right now, the end mill is only cutting on the near side of the keyway, near to you of the keyway, which gives us a conventional type of milling cut. I don't like the climb mill on this machine because it doesn't have a backlash eliminator on it. And I get fine surface finishes with conventional milling, so set 30 the other way to this side of the keyway. There we're at 0. You can hear it cut as we sink it into the wall by 30 thou. It's like a commercial for Kurt Weiss's. This type of work really beats the shit out of end mills. There's essentially no way to prevent unless you use like high pressure coolant that can blow the chips out, which I can't do in this case because it'll just make a mess. You can do that on a CNC machine where everything's closed in. But unless you have something like that, it's virtually impossible to stop the swarf from being drawn in and recut by the end mill. And that's pretty hard on the cutting edges. So keyway machining is pretty tough on end mills. Now we go to 34. In fact, I'm going to go 34 and a half because I think this end mill has probably received some wear since I did the finishing passes on the last one. And since the width isn't extremely critical, I'll just go an extra half a thou. That'll give me an extra thou on width, which may actually come out exactly what I want because of wear on the end mill. Same as before, but 34 and a half. normally I'd be much more aggressive with the blowgun, but I don't want you guys to get soaking wet. It's very, very, very close. No side to side loop. Okay. Maybe on the verge of being a little snug, but I think once I deburr all the thread press, the thread profile I mean, yeah, it's actually not, I think that's what it is, because it's getting easier to move, and I'm not wearing the sides out. That's just little burrs that are inwards that are. Yeah, I think that's good. That's a nice sliding fit. Good. So now deburr all these. I found the wire wheel is the best way to deburr these. Otherwise, with all those threads you'd have to file, you'd be here for most of the day. Well, I think we'll bring this part of the video to a close. There's more work to do to it, but I think I'll put out a second video and show that. This one's getting to be pretty long. I got very little footage there of the deburring. My camera, my old phone I was using to film that, ran out of memory. I didn't know. Ran out of memory while I was doing the deburring. So that was all I got, but it's just wire wheeling. It's pretty simple. That's what the deburring looks like. It actually does a pretty nice job, considering that that's a that's a tough feature to deburr with a file. It's a lot of work to file all those edges, and it took about, I don't know, a minute and a half to wire wheel that. So, but that's the fit. That's the one we just machined, and it's on the key. There's no oil or anything on this, so it's just metal on metal right now. So it's a little bit, it slides easy for metal on metal, and what you're hearing is the tiny bit of play between the key and the keyway. So it's a good fit as well, and similar to the first one I did. So yeah, so that part of it turned out well. The next part of this job is to set up and drill the hole for the roller shaft, and but like I said, I'll do that in another video. And I think I'm also, at the end of that video, I'm going to put an update on the clamshell bucket project, which was a project I did about 4 or 5 years ago, to redesign and rebuild a clamshell bucket that all in all was a really good bucket, but had a pretty kind of a fatal design flaw, and by the time the buckets were about 2 years old, they would just completely fall apart. Anyways, I redesigned it and rebuilt several buckets for my customer, and I just saw one a little while ago after about 4 years of service, and it's still in really good shape. So I thought I would include some pictures of that if anyone is interested, and it you know, kind of confirms that the original design was awful and the changes I made worked pretty good. So anyways, that'll be in the next video. We'll see you later.